Okay, so we are going to be talking about 11.5, which is area of similar figures. So we're going to be able to use the area of one figure and use that information to find the area of a figure that is similar to. When it's similar to, it's the same shape. It just might be smaller or larger, but it's the same proportions. So we did similar triangles back in, what was it, chapter 7? So we're going to do something kind of like that. So when we do our similar triangles, we will have our original shape, like I have this rectangle here with sides of 3 and 8, and I have a new shape. So if I say I am using a scale factor, SF is going to stand for scale factor, and I say my scale factor is going to be 3. So scale factor is equal to 3. I'm going to take all of my side lengths and multiply them by 3. So take 3 centimeters, and in order to find this side length, I'm going to take 3 times scale factor. So that's saying 3 times 3. So this side length is now 9 centimeters. I'm going to do the same exact thing for my 8 centimeter width of my rectangle. I'm going to multiply that by the scale factor, which is 3. So 8 times 3. 8 times 3 is 24. So I have 24 centimeters. Now I'm going to find the area. So my original shape, this rectangle, I take the area, which is 8 times 3. 8 times 3 is 24 centimeters squared. So my area is 24 centimeters squared. And I can use these two side lengths to find the area of my new rectangle. So that's saying 9 times 24. 9 times 24 is 216. So we have an area of 216 centimeters squared. Please, please, please do not forget that. Now, I want to compare this a little bit. I'm going to move some of this. I'm going to move this over here. There we go. And I want to compare these two areas and see how they differ from each other and see if there is a trend that follows. So I'm going to take my area of my bigger um, rectangle and divide it by the area of my smaller rectangle. So I'm going to take 216 and divide by 24, which gives me 9. So if you think about that scale factor, the scale factor was 3, and the division of 200 of my two areas, 216 and 24, gives me 9. What is that relationship between 9 and 3 that might relate here? So think about that for a second. When we look at area, what do we do to our units of measure? So what's written next to my centimeters when I'm talking about area? It's centimeters squared. So when we are doing scale factor, when I go from a side length to a side length, I just multiply the scale factor. But if I'm going from one area to another, I am going to multiply using scale factor squared. Scale factor squared. So this is equal to my scale factor squared, which was 3. 3 squared is 9. So in kind of a summation of this, we take any of our old dimensions. So that could be the length of a side. That could be a radius. It could be many things. And to get our new dimension, we multiply that by the scale factor, whatever number is represented by that scale factor. But when we're doing area, we take our old area, we multiply it by the scale factor squared to get our new area. So we multiply by scale factor squared. Typically with these problems, I work left to right. So if I'm comparing two shapes, I'm going from the left shape to the right shape. So please be very careful when you are comparing these. Some people do largest to smallest or smallest to largest. That's fine as well. just be very clear which direction you are working in so you don't mix up your scale factor. So let's take a look at an example. It says, if the side length of a polygon is multiplied by 4 to create a similar polygon, what will that area be multiplied by? So our side lengths are multiplied by 4. So if you look back up at our chart here, it says old dimensions are multiplied by scale factor to get new dimensions. So we took a side length and multiplied by 4. But if we take area, we're going to take that old area and multiply it by scale factor squared. So I'm actually going to take that 4 and square it. So we are multiplying it by a scale factor of 16 for area, just for the area. Now, if I was to look at the area of a polygon that's multiplied by 25, so the area is multiplied by 25 to create a polygon, what do we do to the length? So again, look at your chart. It said area was done by 25, which is scale factor squared. So for the length, I need to look at just the scale factor. So I'm going to get rid of the square. So I'm going to square root it. So I'm going to take, you can say scale factor squared is equal to 25. To undo that square, you square root both sides, guys. And scale factor is equal to 5. So we're multiplying the side length by 5.